Okay, in this video we're going to look how to do a CFD simulation on our Formula 1 car. So from the App Store, if we come to simulation, the one that this is about is called SimScale. Now, unlike the ones we've done so far, it's not an integrated cloud app, it's a connected cloud app. So you don't need to do anything in OnShape specifically, but you do need to click on Go to Connected Cloud Application. After you've made an account and logged in, your dashboard will come up. You can see there's one I've already been doing to test before this video, but you are going to see nothing and you're going to do a new project. And we'll give it a name. It has to say on public, and annoyingly we have to enter 5 words at least. And we're going to ignore this section for now because instead of uploading, we're going to import from OnShape. Okay, this little button here will take us in to edit our project. And we can see already from the tabs across the top, this is a 3-stage process. First thing we need to do is to create a mesh, and to do that we need to bring in geometry. So there's an import button, import your models from OnShape. So once this box loads, there's no way to actually filter any of your files. You're going to have to do a lot of scrolling, but then you can find your file and click on the assembly, and once you've done that you can click import to bring it into SimScale. After a little while you will see in the window behind that your model has loaded, so you can close this box. So we can see on the sidebar here that meshes still has a red circle, which tells us we need to do something. So we're going to come up to our geometry and click new mesh. And now we get into the important settings. So the one we want is the hex dominant automatic, and we know that because it's a wind tunnel external flow. The fineness is to do with the quality. I'm going to go for number 4, very fine, and we'll turn up the computing cores to speed up exactly what's happening here. Now this one here, we need to come to edit, and this is basically going to set up the box around the car. You can see it's highlighted in blue here. Unfortunately, the dimensions aren't very easy to follow, so you kind of need to play with the numbers and eyeball it until it looks like a good wind tunnel size. I'm going to look at the y-axis here to do the left and right first. So I'm going to increase this one quite a bit. Let's put it up to 0.09. And then we'll do a similar resize on the other side. Might even go a little bit bigger, so add 1 for that one. And another 1 for that one. That looks better. Okay, now I can do the X direction. In front of the car you do need some more, but it's not as crucial as behind the car. So for behind the car, we're actually going to extend this quite a long way, probably even further than that. And in front of the car, the other X will come just a little bit, probably more than that. Okay, the last one is to spin around the camera. It can stay on the ground because the car sits flat, but in the Z direction we need to increase the +1 by enough room to have space above the car. That's probably enough there. Looking at this, I think I still want a little bit more of the X behind the car. Okay, and that should be good. So we can click Save. And come back to our mesh operation. And it says ready to run. So now we can click and we can go to start. You can see our operation has started down here. It's queued and ready to be sent to the cloud. Typically it can take a little bit of time, so maybe check back on it in half an hour or so. Okay, eventually our mesh will be finished and we'll be able to expand Assembly 1 mesh and have all of these things here. There's only one more step until we switch to the Simulation Designer tab, and that is to save some of these faces. So if we go to Topological Entity Sets, you can see there's nothing in there. So we want to start assigning them. First we're going to do the long sides and the top, and we're going to say new from selection. I'm going to call this one tunnel sides. We can now use our new shortcut to hide that, and we can see what's happening inside. We're going to add another one, tunnel entrance, hide that, add another one, tunnel exit, tunnel floor, and then finally everything that's left. So we just have the car left to make a selection with. Unfortunately, it's a collection of faces, so it won't work later on if we pick it as a volume. So instead, we have to pick it as faces. We can go and click them one by one, which is very difficult. We can also expand this and click the faces one by one. We can be a little bit smarter and activate the box selection, drag a box around everything, and then create new from selection car. It's very important that it says it has faces, not a volume there. We now have a tick next to everything, so we're ready to switch to the Simulation Designer. And we're ready to start a new simulation. Okay, so we are doing fluid dynamics, and we want incompressible. And then everything down here we're going to leave as is. This is a very mathematical way in which everything is calculated. We have two options here. Steady state, we want to know at any given time what the airflow is doing over the car, because the car is pretty consistent through the air. What you would use the transient one for is if you were calculating gusting wind over a building, therefore the amount of wind would be changing over time. We can save this. And once again, we work our way through the various things. So let's click Assembly 1 Mesh and save that. Our entity sets have been saved from before. They're about to become very important. Okay, a material. We're going to come to new. Okay, this dialog will come up here, and we're basically going to import our material from the library. And what we want is air. So we scroll down to the bottom and we save. We don't need to change any of these numbers. And then for our assigning volume, we make sure it's still on volume, and then we click our big wind tunnel cavity, and we are saved and done with that. Okay, if you've got an extra material 1 listed here, we don't actually need that, so you can come to the drop down and delete it. Okay, initial conditions we're not going to change. You can have something like pressure or moving air at the start of the test. We're just going to have 0 for everything like that. Boundary conditions, however, is extremely important, and we need to set this up properly. Okay, the reason for making our entity sets will now become clear as we set these up one at a time. So we're going to have one called tunnel in, and that is a velocity inlet, and the area for that is our tunnel entrance. And we want that to be 20 meters per second, and we can see from the arrow here that's going to be the X, because we want it to come in this way. However, the X is pointing to the right of the screen, therefore positive 20 would be in this way. If we want our airflow to go from right to left, it becomes a negative number. So let's put in minus 20 here and save that one. We might hide our tunnel entrance and come back and do another boundary condition. This one is tunnel out, and it needs to be a pressure outlet. Basically, this gives the moving air somewhere to go. We leave all of this as 0 and we assign it to the tunnel exit. Save. Okay, this one is the walls, and we want to set them to walls, and we can hit our tunnel walls entity set. And very important here, we want it to set it to slip. That means it's not going to try and calculate any type of aerodynamic drag or interference from the walls. We're only interested in the car. We don't care about the walls, so by setting it to slip, it'll allow that to happen. Next one is probably the trickiest, and that is the tunnel floor. We're going to go to wall once again, except instead of no slip, we're going to have moving wall velocity. If you think about the car going down the track, it's going to be moving at approximately 20 meters per second, and therefore relative to the car, the track is moving backwards at minus 20. So that's what we're going to put here to keep it accurate. We'll call this track. And then we have one more, and that is the most important one. That's the actual car, so we'll call it car. And once again, it counts as a wall, but this time we need to leave it on no slip, which means it will be calculating how the air interacts instead of slipping past. You can click the car for that, save, and we have successfully applied all of our boundary conditions. Next thing we need to come down to is the simulation control. Basically, we can leave most of these things in place. The maximum run time is probably worth putting up to something like 10,000. That's basically a time where it kicks in and ends the simulation if it's still going. If you've got something really complicated, you'll need to make this a really big number. Otherwise, it will potentially go forever. The way it works is it keeps on solving and iterating over and over until everything becomes predictable. Then it decides that must be how the air is interacting with the car. Number of computing cores up to 8, just to speed it up a little bit. And everything else we're going to leave as is and save. Okay, one more thing to do. Result control. We're going to go to forces and moments and go to new. And we want to assign the faces of the car to this. This is going to help us later on to calculate drag and things like that. We can leave everything else here as is. I'm going to call this one car surface. This will tell us if the car is trying to rotate, how much force is on it, everything else. If you really wanted to, you could come back to and add a new one just for a single surface, for instance the front wing or the rear wing or the wheels, and then you'll be able to get numbers independently for that. But for this demonstration we have enough detail. So we follow the next red one and we come to new, and run 1 is a perfectly good name, and we start to get our results. And depending on the detail that you've put in, how fine your mesh is, things like that, it's probably going to take a few hours. So you can close the browser, come back, check on it later on. We'll actually send you an email when it's complete. Okay, this one didn't take particularly long, but you can see the bar is at 100% and all of the graphs have more or less stabilized. That's how it knows when to finish. It's at the start here they're changing a lot, but the values start to tail off, and it means we're ready to go. So we can come to the post processor. This is the third stage, and this is how we look at all of our results. The first and easiest thing to look at is the force plot, and we set one up called car surface. This is going to be another graph. We don't need most of these things, so we can click to hide them. Pretty much the only ones we need are the top 3. Okay, remembering that at the end is the important part because that's when it's the most stabilized, and we have our various directions. So we'll see zeros at the top here. Y is the side to side across the car, and as you would expect, that's pretty much 0. You wouldn't expect the car to pull left or right. Z is the up and down of the car, and we have minus 0.04, and that is in newtons. And then the drag of the car is minus 3.59. So if you're doing back-to-back tests, you'd want to get that number as small as possible. Now, in terms of this one, you need to look at the arrow in the 3D model to work out whether a minus is downforce or lift. I think from memory, the arrow was pointing to the top of the car, therefore a minus number means the force is acting downwards, and this car has a marginal amount of downforce. To look at something graphically, we need to click on solution fields, and after a few moments, the interface will load in the middle. Okay, when this interface loads, you'll probably find it quite confusing. We can use the left clicker to spin the camera around, but you'll notice there's a delay on it. That can be very frustrating. The reason that is because it renders in the cloud and then sends the images through, so there's a little bit of a delay before that happens. We have our run 1 here, and then we have all of these parameters down below. Most of them we do not need to worry about. The first thing we're going to do is to come down to where the solid faces start, scroll to the bottom, hold shift and then click to select all of those, and then go to apply. This will turn on only the car and hide everything from the box around it. Okay, that's much better. Now once again, there's a lot of data here, but we really only need to know about 2 of them. P is for pressure and U is for airspeed. So if we put this to the point data to go on the surface, the shading should change to show us the high and low pressure areas of the car. We can use the scale button up the top to do auto range. That will set the high and the low automatically. Otherwise you can manually put in the numbers. And then from the view, we have a fast way to spin around the camera and to save screenshots. Okay, so as we might expect, looking from the front of the car, we have some higher pressure areas where the wind hits the car, and then from other angles we have some lower pressure areas. Also from the view menu, we have the ability to turn on and off things like the origin and axes and things like that if we don't want them in our screenshot. So I'm going to use the middle mouse to pan this to the side, and then click and hold the right mouse to zoom in a little bit. Once again, from the view menu, I'm going to click generate screenshot. Okay, that's just one type of result we can do, but one thing that's really confusing about this is whenever we want to add extra views and things like that, we need to come back to solution fields and add the result to the viewer. So that will put in another default one, and I'm actually going to hide my original one and click on this one to bring it up. And this time I'm going to leave it just on the internal mesh and all of these, because I want to deal with the area that's around the car instead of the actual car. And making sure the new one is highlighted, I'm going to come to add filter, and I'm going to go to stream tracer. Okay, so I cannot see the car underneath because the run one we've just added is the area around the car, therefore it's not going to show the actual car. So I need to hit the eyeball to show the car once more. and now I have a good idea of what the airflow is doing over the car. Now at the moment it's set to P for pressure, so really we want that on the U. And this should give us a good idea of where the air is speeding up and slowing down. You can see down the bottom here we have some different options. Once again, we don't need to look at all of them, but things that you might like to do is increase or decrease the amount of points, maybe change the area in which they show up. So by making this radius smaller, it will be a smaller collection. They won't fan out as much over the car. And if you really want to play with it, you can change the center point to put them over a specific part of the car. You might put it down to only 20 points, but over just the front wheel to see how it interacts around the wheel. I'm happy with that one, so I'm going to come up to view and I'm going to generate another screenshot. Okay, time to add another type. So once again, we're going to right click and say add result to viewer. It will come to the top. We need to click it. And once again, we want it to be the internal mesh, which is all of the area inside the box, but not including the car. So basically the air around the car. So we can leave that as it is, and we're going to add a filter, which is clip. Clip, split something in half. Okay, you can see our airflow volume is split in half, but it's going the wrong way. So we have X, Y, and Z axis. We need to change it, in this case, looking at the arrows, to the Y. Okay, now up the top, we want to make sure it's on point data, and then we're going to switch the view to be looking from the Y direction. Okay, so at the moment there's probably too much going on the screen to make any use of this type of data. So we're going to turn off the stream tracer from the view. And the other thing we're going to do is to click back on run 1, and we're going to shade the car just in grey so it's a little bit clearer what's happening. So up here where it talks about our color coding, we're just going to set the car to be a solid color. Okay, that's a little bit easier to tell what's going on. And now when we spin the camera around, we'll have a pressure map of the air around the car. So we can see that there's high pressure just in front of the wing, and then it speeds up again over the nose cone, and then a little bit higher pressure as it touches this surface, and then speeds up again. To help us understand what we're seeing, we can come back to clip 1 and turn on the color bar. Okay, and it tells us in pascals our pressure, so we don't really have anything in the minuses. We only have areas of high pressure, so there's no suction anywhere on the car. Okay, we're going to do one final type of visualization, and we're going to hide our clip, and for the last time we're going to right click and add the result to the viewer. Okay, once again we're going to deal with the area around the car, which they call the internal mesh, because it's inside the outside of the box. And this time the filter we're going to add to it is a contour filter. Okay, this one will need some explanation. It's quite confusing. So basically this value here, which is in pascals, as designated by this, will tell you all the bits that are this type of pressure. So for instance, you could put in a pressure of 0 and it will tell you all of the bits in the model that have a vacuum, or you could put in an area that you consider high pressure and it will highlight all of the bits considered to be higher pressure. It's worth playing with these different settings here, and another thing you might like to do is to put down the opacity. This works for any of our visualizations. So right now I've put it to 50%, and I might change this number to be minus 50 instead of minus 98. And it will update with all of the areas that have that amount of pressure. Okay, for the final time I'm going to come up to view and I'm going to generate a screenshot of that. Something very important here is to go to the save state. If you were to reload this document, everything you've done here would be lost. So it's important to save the state. That will now appear down the bottom. We can get to all of our screenshots that we took, download them, save them. You can pump out as many of those as you need to. And next time you open it, if you come back to save viewer state, you have all of this here, and you can come back in, fiddle with whatever you need to, take more screenshots without having to set up all of that again.